But if I give you an angle, you're going to find out soon, I hope sooner than later, that it's almost still like the same thing. What I mean is it's still going to be a triangle. It's still going to be a triangle. It's still going to have positive and negative dimensions. And then that little quiz that you just took, it's going to end up fitting with those same definitions. Okay, so if in the next 5 minutes it kind of crosses your mind that this kind of seems like the same thing, perfect. It is kind of the same thing. The only difference is that I'm giving you an angle. Okay, basically to get started. I'm giving you an angle to get started. What I want to do with the lesson today is kind of develop it with you in a way that gets you to do some thinking. So we'll bring out our thinker Bob guy. But what I'm suggesting here is that maybe there's something that you could do to kind of think about a triangle and the sine of 60. So we're trying to think about a triangle as we think about the sine of 60. Now, if you're like, whoa, wait a minute, the sine of 60, that's new. Right, that's new. We haven't officially done that. But I wonder what we could figure out about a triangle as we think about 60. That's kind of my hint to you that we really need to just focus on 60. Okay, now let me just do something that I don't think ruins the fun. I'm going to draw 60 degrees. So now what? Suggesting now what could you do that we've done before?
Make it a triangle next time.
I don't know if you're doing that in your sleep, but is it almost becoming kind of like the thing to do? Is it sort of like instinctive? I'm just saying the only thing that we got to be careful about, and Chase said, with the x-axis. So making these triangles, it's the thing to do. With the x-axis was a good call. What do you know about this triangle? Sine, cosine, tangent, cosecant, secant, cotangent, otherwise known as Riley.
I was just gonna say, like the angles, like the 90 degrees, 60, and 30.
Oh, that sounds like it has like a little ring to it. 30, 60, 90. 30, 60, 90. Now, if you're like, does he expect me to know something about 36, 90? I don't know if I expect you to know, but I do expect that you realize that there's something true about a 30, 60, 90 from prior knowledge, from geometry. What I'm suggesting is the sides of a 30, 60, 90. It's known, okay? It's not something that we have to like dig too deep. Across from 30, and by the way, the reason I'm picking 30 is because that's the smallest angle. So across from 30 is the smallest side. The smallest side. It's okay. If you don't remember it, then I'll just kind of say that we always call that 1. Okay, now I don't want to get in a big conversation about, well, why? That's like a geometry thing, but basically that's kind of like the base unit. That's like the smallest side. So we start with a 1, and then normally you go to the hypotenuse, which unless you remember close, I like that you're thinking, Nate? 2, good. Again, if you're like, why? Okay, it's just true that the hypotenuse is always double the smallest side. Okay, again, kind of go back to geometry, but 1, 2, the last side. 1, 2, 1, 2, what holds a tree in the ground? Root. How many stooges are there? 3. Now listen, here's the main thing. In a 30, 60, 90, it's always going to be a 1, 2, root 3. I'm going to go over that again, but that's just a true statement. Let's do the sine of 60. Ready? Oh, wait, that's just y and r. Awesome. I've got a y and an r. I kind of feel like I've been here before. You have been. You just found the sine of 60. Okay, it's root 3 over 2. Now, I guess I can't help it, and maybe you're good with it too, but what the heck is root 3 over 2? In its essence, it's a y value. It's a y value on the unit circle. See that point right there? The y value of that point is root 3 over 2. Okay, that gets a little deeper into the theory, but we kind of want to not forget that. By the way, that triangle, it's bigger than the unit circle. Feel like you've heard that before? If you're bigger than the unit circle, it's okay, because the definition y over r just scales us back to that point. Okay? It's trigonometry. Let's kind of do the same thing, meaning let's see if we can think about some stuff that maybe we actually know, even though this is new. So I've got the secant of 45. The secant of 45. Remember, this is new. Like, I'm giving you an angle. I'm giving you 45 degrees. It turns out, though, that it might be the one that kids like the most, because, geez, if I give you 45 degrees, again, I don't think I'm ruining your fun by saying we could sketch that. And so now the fun begins. Now, what can you do? What can you do? Just to keep this rolling, I would hope everybody would say, you can draw a triangle. So now what's true about this triangle? Mason? So what do you guys know about a 45, 45, 90? Ah, crap. I mean, I got to remember something else from geometry. Well, a 45, 45, 90, the legs are always the same. Good. They're the same. Okay. That's why we actually pick like an easy number to describe that. 1 and 1. And now you get like a little jingle. It's called a 1, 1. We're looking for the hypotenuse. 1, 1. Okay. Again, it's just a recall thing. It's not 2, but it's close. Root 2. Listen, for my students that are like, why is that true? Pythagorean theorem, a quick Pythagorean theorem of 1 squared plus 1 squared will give you root 2. Ready to do the secant? Okay, that's my way of saying we're back to where we've been. Secant's r over x. I think I have an r. I think I have an x. I have the secant. It's weird. Take a look at this little diagram of kind of what is happening here. You decide if you want to write down the diagram or the little chart, maybe just read it, but just kind of want to make sure we realize what you do if you're given an angle. If you're given an angle. And it's mainly right here. You're going to make a sketch. You're going to make a sketch of a triangle. Okay, now you'll find out the main part of today's lesson is making sure that we remember these special triangles. So we have a 1, 2, root 3. We have a 1, 1, root 2. I didn't put the triangles up on the PowerPoint. A little too much work. Maybe you want to draw even though you'll be drawing the same thing, maybe you want to draw the 1, 2, root 3. Okay, so I'm saying in your notes, maybe you want to put down 1, 2, root 3 instead of just writing that. So that's the 30, 60, 90. And then the 1, 1, root 2. I mean, it's going to be the same thing I just drew here, but if you want to kind of put it in your notes, here's what you have to understand. The sides, whether it's 1, 1, root 2 or 1, 2, root 3, they always have to match this way. Okay, so again, across from 30 is always the number 1, always. The hypotenuse is always 2. That makes the longest side, or excuse me, the side across from 60, that makes that root 3. And then for this guy, usually pretty easy to remember that you get a 1 and a 1, but the hypotenuse has to be root 2. I want to do a couple more problems that will sort of say something else to us. So listen as it says some things to you. So the tangent of 150. And actually, just to help you with your homework tonight, which I still need to post, if we're going to do the tangent of 150, we could also do the sine and cosine. So let me present it this way, because you're going to actually be asked to find all three. But whether you're finding sine, cosine, or tangent, the real conversation right now is what are you going to do with 150? So let's talk about 150. There's kind of something for it to say. Let's let it talk. Here's 150. Okay, so all problems are going to create a triangle, just like it says up here. But there has to be a point where we start to realize like exactly the dimensions. So what angle do you feel like you know, Isabel? Good. Now that's kind of where I was wondering if we would hit that idea. So you found that to be 30, and you're exactly right. Now, do you realize, and this question is for everybody, do you realize what angle we really just found? It's something from the first day of school. It's the reference angle. It's the reference angle. Now, if you're like, oh, I didn't realize that, but I still did it. Awesome. Okay, that's the idea here, that you just kind of instinctively knew that these numbers are going to produce a 30, as Isabel said, at that angle by the origin. It's the reference angle. Okay, so it's okay if you did or didn't say, but let's make sure we get the sides correct. Across from 30. So across from 30, that would be this guy over here. That's going to be your 1. Okay, the hypotenuse, that's going to be your 2. That means the other one is root 3. But there's a little mistake on the board. You have to kind of be paying attention to details. There's a little mistake on the board. Don't worry, we're not going to erase it. We just need to blank. It's not a mistake from today. It's something from yesterday. Why? Great. Okay, process that. Like, let that sink in. That's the number one thing kids need to realize. Positives and negatives. Okay, now we can do the sine, cosine, and tangent. Okay, I had asked you to do the tangent first, so that's y over x. but we could find the cosine. Notice the cosine answer has that negative in it, and sine, we can get that one too. Okay, so sine is 1/2, cosine is negative root 3 over 2, tangent negative root 3. Look, if this helps you, it's your notes, but look, reference angles. That was kind of like the natural thing that happened in that problem. Whether you realize or not, we used a reference angle. Okay, again, that was that 30 degrees that Isabel found. So you're going to have to find those also. And it probably will just kind of be instinctive to use a reference angle. And then, of course, always be aware. Always be aware of positives and negatives. We're going to do one more prob here. Sine, cosine, and tangent of 225. Again, the focus really is on the 225. Kind of wonder if you feel like, I hope you feel like that you can maybe even get most of this rolling. So I'm just pausing on purpose so you can try anything that you think would be right as you work out 225. I'll tell you what, nice job. You guys have really hit this well. You're taking care of details. I don't know if you realize quite just how important all these things are, but you're doing them correctly. So when you realize this was a 45, 45, 90, and you put down 1, 1, root 2, or rather -1, -1, root 2, that's a key idea, using those negatives just because you're in a negative place. That's a negative x, that's a negative y. But you're right, okay? Just put these numbers into each definition. Now, be careful. You know, that's good. You're going to get some credit for that, like maybe 80% credit, but I'd like you to get 100% credit. Square roots are not supposed to be down there. So you really do have to clean that up. For some of you, that's the only thing that's giving you trouble. But it turns out to be the same answer for cosine. And then tangent, a couple -1s equals 1. Now you might be saying, I feel like I've seen some of these numbers before, especially these two right here. Well, yeah, because those two numbers represent that point. That point right there, of course, is back to the beloved unit circle. Okay, and it's going to be equal. It's going to have an equal x and an equal y. It's known as -√2 over 2. given an angle. Okay, given an angle. Now, what you got to be careful about is that you don't forget how we did last night's, where I gave you a trig value, and then even the night before that. We will kind of put it all together, though. So for now, we're just working on an angle. There's a homework helper, and again, I need to get that posted. I'm going to do that right now. All right, I think that about wraps things up.